You're here because you want to learn chemical energetics from a University of Cambridge graduate. Let's begin. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today. For your chemical energetics, this involves the energy of chemicals, right? And there's two kinds of reactions in chemistry that you have to pay attention to with regards to energy. The first is your endothermic reactions. So these endothermic reactions absorb thermal heat. They generally lower temperatures, okay? And for these, you usually want to think about bond breaking, and I'll get to that later, right? And some examples of endothermic reactions which you have to memorize, okay, it's like your melting, your boiling, your dissolving, thermal decomposition, and photosynthesis. Alright, the other one is your exothermic reactions. So this release thermal heat, right? And of course, they are going to increase the temperature through these reactions. So for these, you always want to think about also bond forming, right? Some of your common reactions, okay, which is something you also have to memorize, are your condensation, your freezing, your combustion, and your neutralization. In this topic, you also have to know several definitions. So bond energy, right, is the amount of energy absorbed to break 1 mole of a covalent bond, right? And we'll get to how bond energy is kind of used to determine energy changes in a reaction. Activation energy, right, is the minimum amount of energy that is needed for colliding particles in a reaction, okay, to have a reaction. Then we have enthalpy. Enthalpy is just the total chemical energy of a substance. And with that, this term that you're going to see a lot of is called enthalpy change in this topic. Enthalpy change, in other words, is just the energy change in a whole reaction. This is usually presented in kilojoules per mole or joules per mole. So remember how we have two types of reactions, right? In an endothermic reaction, right, there is going to be a net positive in our energy change. So the energy level of our reactants, right, is going to gain energy as it goes about the reaction, and when it gains enough energy, which is the activation energy over here, right, it's going to come down in energy level to the product energy level. The difference between the reactant energy level and the product energy level is the enthalpy change. Since it is a positive difference, means the energy of the product is higher, right? It's higher than the energy of the reactant. That means that enthalpy change is positive, and that means this is an endothermic reaction. Now take note, you also need to learn how to draw this whole graph, right? And take note of the y-axis and the x-axis labels. These are something you have to memorize. You will also need to put the specific reactants and products inside the energy profile diagram instead of just putting reactant product. For exothermic reaction, very similarly, we can draw energy profile diagram. And remember, it is going to be from a reactant energy level. It's going to gain enough energy until it reaches activation energy, right? And therefore a reaction can happen. And then after that, it will drop down to the energy level of the product. What happens here is that the enthalpy change is negative this time. So the energy level of the product is actually lower than the energy level of the reactant. Okay, and this is what we call an exothermic reaction. Usually this difference in energy level is what is produced as heat most of the time, okay, and that's why you will feel a higher temperature increase. So what is the relationship between bond energy to my enthalpy change? You must first understand that bond breaking, right, generally absorbs energy. You need to absorb energy to break bonds, right? And so bond breaking is generally endothermic. Versus your bond forming, this is releasing energy. It's the opposite of bond breaking. So it will be exothermic. So overall, right, your enthalpy change is just the sum of all your bond energies, right, for your bonds broken. If you take all the energy of your bonds broken and you sum it all up, right, okay, this will have a positive sign because you're inputting energy into the reaction. And then you minus the sum of the bond energies of the bonds formed. This bond energy of the bonds formed mainly has a negative sign because this is energy output, right? So if you have the sum of the bond energies of your bonds broken minus the sum of your bond energies of your bonds formed, right, this will give you the overall enthalpy change of a reaction. And yes, you are expected to do this calculation in your tests and exams. For those of you who are wondering what this sign is, this sign just basically means the sum. So once we know this, okay, we can take these necessary steps to calculate the enthalpy change with our bond energy. So first, you always want to draw out the full structural formula of all species in a chemical equation, right? This is so that you can clearly see all the bonds. Most students don't do this step, and that's why they make careless mistakes in their calculations, because they miscalculate the number of bonds. Then you want to calculate the total energy of the bonds broken. Then you calculate the total energy of the bonds formed, and then you will calculate enthalpy change using the equation above. So let's take a look at an example question. The complete combustion of hydrogen is represented by this following equation. So they're very nice, they give you the balance equation already. And then you want to use the bond energies given to calculate the energy released on burning 1 mole of hydrogen. Okay, and they give you a list of bond energies over here. So how do I go about doing this question? First, you want to rewrite the equation but in its full structural formula form. So we know that 2H2 plus O2 gave 2H2O based on the equation above. Let's just redraw it in terms of its structure. So H2 is just H single bond to H covalently, O is a double bond to O, and then H2O is just H single bond to O and a single bond to H. Remember, it's H2O, not HO2, right? And then you want to count the number of bonds. Okay, there's 2 of this HH bond, there's 1 O double bond O, and there's actually, you have 2 H2O molecules, so you actually have 4 OH bonds that you're going to form. Okay, this is where it gets very tricky, right? So it's always advised to go and draw it out to calculate the number of bonds properly. Then you're going to calculate the energy of the bonds broken first. So here I'll put a label over here. So energy of bonds broken, okay, equals to, so we have 2 HH bonds and 1 O double bond O. So it's actually 2 times 436 plus 496. So if you do the calculation properly, you should get a value of 1386 kilojoules. Right? Next, you want to find the energy of your bonds formed. And this will equal to, so we have 4 OH bonds, so this is just 4 times 460, and this will give you a value of, if you do your calculation properly, this is just 1840 kilojoules. So the total enthalpy change of this whole reaction, alright, is just the sum of your bonds broken, which is 1386, minus the energy of the bonds formed, which is 1840. And this will give you a value of negative 454 kilojoules. Now, if you think this is the final answer, you need to really be a bit more careful, right? This negative 454 is for the energy released on burning 2 moles of hydrogen. The question asks for specifically 1 mole of hydrogen. So in this particular case, right, the real enthalpy change that you need to find, so let's do a label, 1 mole of hydrogen, you just have to divide by 2. So it's just negative 454 divided by 2. And this will give you a value of negative 277. Okay, put the kilojoules per mole with the sign. And this is how you do a calculation of your enthalpy change according to the question based on the bond energy. If you enjoyed today's video, do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.